R. Young. Johnryoung.
All right, thank you. And today's date is October 22nd of 2013.
I'll agree on that.
Okay, sounds good. And we're conducting this interview on the campus of Washington State University, Tri-Cities.
Yeah.
And so let's start, if we could, by having you tell me when you came to Hanford, what brought you here, how you got here.
What was that?
When did you come to Hanford, to work at Hanford, and what brought you here?
You want the whole story of
Yeah.
how I got to Hanford?
Yeah.
It'll take me 15 minutes. I wrote a letter up to here after I saw an article in the newspaper saying they were looking for employees. And after that, they accepted me from the standpoint that they would find out whether or not I was qualified. And for the next 2 months, the FBI and other agencies went through my history, got information from my doctor and so forth. And in early June, they finally decided that they would offer me a job, or they offered me a job.
And so where had you been living before you came here, and what year was this also?
What was that?
Where were you living before you came here, and what year was this that you moved here?
Oh no, I didn't have any employee here before.
No, but where did you live before you came here?
Where was I working?
Where did you live before?
Oh, I lived in Albany, Oregon. And I worked there as a carpenter because my dad made houses. So anyway, when I found out that I was supposed to arrive here on July the 8th, I started from home on July the 7th. I wanted to be sure that I got here. Now, something I should tell you now is that during that spring, the Columbia River was at its highest violation, you might say, or amount of water in history. And it had wiped out parts of Portland, and there were only 2 bridges on the Columbia River in the United States. One was a bridge of the gods down by Portland, and the other one was a bridge up by the Canada. So I didn't have any choice of how to get here. So when I left home, I drove up to Portland on back country roads because the main roads up to Portland were all wiped out by the water. Got to Portland, drove 17 miles east to the Bridge of the Gods, and that was actually a very funny ride because the road I was on the south side of the river and a railroad track were the only 2 things on that side of the river, and I could drive along there and look out over the top of the rails on the railroad, and I could see that the flood was 2 feet below the top of the railroad. Anyway, I got to the bridge safely, went over the bridge, and I knew that the road on the other side going east from the Bridge of the Gods rose gradually up the ridge on the north of the river and eventually go over the top of it and go down into the Yakima Valley. And I got about halfway up that ridge when the engine on my car flew out. I fortunately was right out of a little town there that had some place where they could fix my car. So I spent the rest of that day there while they were working on the car, and they got the car ready for me by 8 o'clock the next morning, which was the 8th. So I drove on up over the top of the ridge, down into the Yakima Valley, because I knew that if I could get into Yakima, there's a main road coming from Yakima down here. I got down to the bottom of the hill there, started toward Yakima, and I got 2 miles, and I found out that there was 3 feet of water over the river, or over the road, pardon me. So I turned around, went back, and there was an industrial area there, and I found a guard there, and it said, "Is there any way I can get down to here?" He said, "Oh yeah, go back up to the road to Yakima, and then go east. And when you get down about 30 miles, there's a bridge over the river." So I took it and went into Richland, getting there about noon on the 8th, which was fine for my getting there. So I ate my lunch, went into the federal building, which was only a 1-story building at that time, and I found out where the manager of personnel, well, new in personnel were. Walked down to his office, walked in his office, and he had about 5 desks in there. He was on one of them right by the door, and he was busy working on it, so I stood there, I'll say, for over a minute. When he finally looked up and saw me, so I reached out my hand to him and said who I was. He stood up, he opened his mouth wide, and he stood there for over a minute, utterly amazed. When he finally got himself together, he said, "How in the world did you get into Richland?" What had happened was the management of Hanford had concluded that nobody would get into Richland for the next month. And that's why he was so astounded that I got into town. Those feds, if you want to call them that, had overlooked the fact that I was a Westerner. I can go anywhere in this country that I want to, because I was raised on a cattle ranch down in Central Oregon, and I knew where to go through the, I'll say, backwoods, and that's how I got there. So anyway, their question then became, what are they going to do with me? Because they had shut down the orientation class for new employees. So I couldn't go to work out in the areas. What were they going to do with me for a month? Well, the first thing they did is they got me a room out in the barracks in North Richland. And then they told me to report to the production scheduling office in the federal building the next day, which was a top secret operation. And the purpose of that office was to determine which tubes in the reactors should be discharged the next time they have an outage at the reactors. You consider that there's 6,000 tubes out there. They had a unique calculation system because they had a calculator which was designed to do that calculation to tell them what the amount of uranium was, or the amount of plutonium was in those process tubes. And such a method of calculating did not exist anywhere else. It was a special calculator designed by Marchand. So anyway, I spent the next month in that office. I had a copy of the manual for Hanford. It was a top secret copy. And I could read that and find out everything that went on in Hanford in their manual. And then at the end of that month, when they finally opened up their orientation operation, I went through that process, and then I went out to the 100 areas to go to work. I was assigned for 6 months at B reactor as an assistant, operator, you might say, for the reactor. It was a training period. It's a General Electric process. Anytime the General Electric company, at that time anyway, hired a new employee that had an education, they would put them out into one of their operations, or many of them, to give that person training on what to do in the job that they're going to get. And when they got through with the 6-month part, as you might say, that I was out there, they then assigned me to day work out in the 100 areas. And I spent the next 17 years out in the 100 areas as a senior engineer, one of the few that they had out there. Now, I had to earn that title of senior engineer, but I was working on increasing the productivity of the reactors, reducing the cost of operating the reactors, reducing the amount of radiation affecting the workers out there. Things of that type for 17 years. At the end of the 17 years, they started shutting the reactors down. So I resigned. Went to the 300 area and joined, might say, several organizations down there. You know, there's so many of them are floating around there. It's funny. And I spent 33 years mainly working in the 300 area. But what I did was such things as licensing nuclear reactors, 7 of them, on the east coast of the United States. Congress had decided that all of the nuclear power plants in the country should be licensed. And the EC, when they got that, they said, well, you should work in the east because we don't want any bias. So those 7 reactors are spread all the way from Florida clear up to Minnesota. And after that was just a typical action, you might say, for, about 1 year. Mm-hmm. I was still an employee here. And if you want to know what I've done for the rest of that 30 years I spent at Hanford, I've got it listed here, if you want it. This is something that I've had to fill it out as appropriate, just so I could answer questions of the type that you made. And if you want to make a copy of this.
Oh, sure. Yeah, we could do that afterwards, yeah.
Yeah.
That'd be fine.
But you see there's, what is it, about 15 boxes on there. So,
well, I want to go back to when you first arrived in the area in 1948. Is that right?
What did I do?
You first arrived in the area?
I just arrived in 40. Well, you mean in the Northwest?
No, I mean in Richland, Hanford area.
In Richford, yeah.
What sort of housing did you have when you first arrived?
There were in Hanford at that time large buildings, some of them still exist, which had multiple rooms for people, and some of those buildings could hold many 25 people. And I was single. It was very handy. In mid-town, you might say. Not out in the sandy places where they talk about in this article. But that sand, you know, he talks in there so much, a couple of times anyway. Actually, it was not Richland, except for little locations where one building might be built. Most of Richland was grassy. And if you're in Richland, you're not getting any sand blowing around. And if you read their article there, they talked about the sand when they were on construction locations. Well, that's normal throughout the whole state of Washington, you might say.
So what were your first impressions of Richland when you first got here?
When I first came in,
Yeah.
I got a story for you that you're going to wonder if you want to publish it. I, like I said, drove into Richland on the 8th of June and got my lunch, ate my lunch, went into the office there, and I guess I told you that this fellow said, "How in the world did you get into Richland?" So from that time on, I was working. And I was working out in the 100 areas. The first 6 months, I was working at B and D reactors. And my position was assistant shift superintendent. See, they had shut B reactor down for, must have been 4 years. Because they wanted to keep it available in case they had to get some more plutonium for the military in a hurry. And that was the only time I was on shift. After that, my work was what you might call typical engineering. Not, you can call it nuclear engineering if you want to, but it's general types of engineering. Reducing operating costs, increasing production, reducing the radiation doses to the employees, those types of things for 17 years. Right. Ended up as a senior engineer.
Of the different sorts of jobs, different parts of the Hanford site that you worked on, was there something that you found most challenging, most or something that you found sort of the most rewarding about what you did?
I don't understand your question.
Well, whether you had at least a few different jobs. I mean, you worked in the 100 areas, right? And then you worked in 300 areas. Were there certain things that you did that you found sort of more challenging, more difficult than others? And were there certain aspects or certain jobs that you had that you really found especially rewarding, that you really enjoyed?
The main difference was that when I was working in the 300 area, the reactors were reactors of the types that were used everywhere else in the United States. The Hanford reactors were very specific reactors because their only purpose was to produce plutonium, whereas the other reactors in the United States were primarily built to produce electricity. It's different design. and it also had more, shall we say, opposition by the public. Yeah. And that's a subject that you might want to address, because the people who are supposed to be the experts on radiation generally refuse to use the information which says that low-level radiation is beneficial. That makes a lot of difference. That low-level radiation is so beneficial. In my case, I got 15,000 radiation dose. All of it was low-level radiation. There might have been some high level in there, but I can only tell you what the badge has, you know. And that's something that you might want to mention in your articles if you publish them. There are numerous people here, in particularly Hanford, that refuse to recognize that fact, that low-level radiation is beneficial. And like I say, there are scores of documents that say that low-level radiation is beneficial.
You talked about your badge,
Yeah.
and what if you talk about safety at Hanford? Was it? Did you have to wear any? You have to wear any special clothing or equipment of any kind to do your work, or what sorts of ways was safety sort of part of what you did?
Well, I was cleared for every type of, you might say, limited information. I got that when I told you I went into that one office on the first day. That was a top secret operation. And top secret gives you access to anything, assuming you had a right to, you had a need for it. I spent, let's see, how long were we in Oak Ridge?
1 year.
1 year, yeah. I spent 1 year in Oak Ridge on a committee which had somebody for every one of the AEC outliers, you might say. And the purpose was to determine where particular materials could be manufactured if somebody needed them. In other words, if you want high-level radiation dose or something. And I was dealing with people from every one of the major AEC outsides.
Right.
So, but I was ranged all over, you might say, in various types of work that involve radiation. For instance, I was a manager of preparing an environmental impact document for fusion reactors. And that document was presented in a meeting to the international fusion organizations in Germany.
About what time period was that? Do you know?
Oh my. Let's see. It must be about 1990. Yeah.
During your years working at Hanford, were there any events that incidents, events, special occasions, things that sort of stand out in your mind from your time working at Hanford?
You mean the reactors involved?
Oh, it could be, yeah. I mean, that's maybe.
Yeah, we had one out in 100 areas for essentially all of the reactors. When they built the reactors, of course, the reactors are made out of graphite. They ran tests on graphite and so forth, and they learned that they could operate the reactors with a fairly low temperature of the graphite. You get too high temperature, you know, it might hurt the material. And as we started raising the power levels of the reactors out there, the graphite started expanding. And the result was that in some of the older reactors, like B reactors, the graphite expanded enough that it pushed the shields off the outside of the reactor, or pushed them apart, you might say. And it formed, and the result was that the radiation inside of the reactor was leaking out through the crack at the top of the far side wall on the reactor. And there was a, you might say, a line of radiation going out that crack, out through the wall on the far side of the reactor, and then up into the air. And the result was that there was about a 20 MR radiation dose on the ground outside of the reactor. And that's one thing I worked on. I went back into the files of the DuPont people. And by checking through those files, I discovered that if we raised the temperature of the graphite, the expansion would stop. And if you go too low, the graphite would reduce in volume. And this, so we had to go through a special study, you might say, to try to figure out what this would do to the reactor. And the result was, you see, the normal tube in the reactor was straight through the reactor. But when the graphite started expanding, the tube went up in arc and came back down because the highest temperature graphite was in the center of the reactor, you might say. So we figured out what was the proper temperature of the graphite, of actually the gas in the reactor, and we ended up with the top tubes in the reactor going in, going down, going up, going down, and coming back up and going out the back. That's the type of things you ran into on something like those reactors. And by doing that, it sort of drove the people replacing process tubes on the reactor, having to figure out how to get the tubes in the circles through the reactor. If we had not done that, eventually the reactor would have fallen apart. In other words, we hadn't figured out what was causing the problem, because the reactor would just keep expanding and finally that outside shield would fall over. Or we'd have to somehow rebuild the shield up there to keep it in place. Yeah. That's just a typical job that you'd have. You know, you might spend 6 months on that. I had another one. I was working with a fellow who was an expert on water purification. And see, we were cooling the reactors with Columbia River water. It had to go through the water plant to clarify the water to get the sand and what have you out of it. And when they first designed the reactors, DuPont had discovered that if you did not have the right concentration of materials in the water going through the reactor, the tubes were bending up in the tube inside the reactor. And in order to prevent that happening, they used sodium dichromate in the water in the reactors. 1 part per million or something like that, but it's still, we're spending about well over $1 million a year buying that material. And I was working there with a fellow who was an expert on operating of water treatment plants. And we got together and looked at the sodium dichromate that was used, and we said, and we were buying that by the railroad carload. I think the total cost was $1,400,000 a year for that one material, as I remember it. And we looked at the price of it, and we looked at the price of buying the 2 components for making that material, and we had enough equipment in the water plants that we could make that material, the sodium dichromate. So we bought the chromate and sodium, and we cut the cost in half, from about $1.4 million down to $700,000 a year. So we saved $700,000 a year. That's the type of things you work on. All types of things you get involved in. For instance, when they built the reactors back in World War II, there was a shortage of steel. So many of the pipes, particularly the ones underground, were not made out of metal. And when you heat and cool the other types of pipes, they start leaking because they crack open. So we had to figure out how to solve that problem or reduce the amount of sodium dichromate getting into the Columbia River. We worked it out, reduced it considerably. Those things get a little complicated. I don't want to go through all the details of it. Yeah.
So involved a lot of problem solving.
Yeah.
In many ways, right? Problems with the reactor or whatever, you would work on solving those issues.
What was that?
If there were problems with the reactors, then you would work on solving some of those issues, work on solving the problems.
Yeah. See, in other words, you have really 2 plants there. One was a water plant to provide the water to the reactor, and then the reactor was the other plant. And what you do with the water to get out of that is just how you get it back into the Columbia River with a minimum of radiation. You know, that raises an important thing that I haven't mentioned to people here in the Tri-Cities. I kept records on what the radiation was in the Columbia River. And when we were running the reactors out there, we were running, you might say, tons of radioaction into the river. Yet the amount of radioactivity in the Columbia River here at Richland was essentially 0. It had disappeared, you might say, or been diluted, if you want to put it the other way, during the travel of the water from out there by the reactors into here. And when I see these articles in the newspaper about they're worrying about the fact that there's radiation out there in the 200 area and it'll leak out into the ground 7 miles or something like that from the river, I would be willing to bet that there wouldn't be much radiation getting down to Richland. And the other thing is that it would be low-level radiation, which is beneficial if it does get down here. I don't know if I want to put anything like that in your what you publish, because those nuclear engineers don't want it to be published.
Overall, how was Hanford as a place to work?
What was that?
Overall, how was Hanford as a place to work? What did you think of Hanford as a place to work?
Well, to me, that was a typical job. In other words, I had to travel 35 miles to get to my work. But people do that all over the country. It was an interesting job because we were working on increasing our knowledge of the subject. It's different than running one of these dams out here where you're generating electricity, you know. All you're doing there, you know, is pushing a button once in a while. But by doing the right things out there, we saved millions of dollars. And we also reduced, you might say, the effects of radiation on anybody by being sure they didn't get any high radiation doses. But the most important thing about it is that we were, you might say, at war with the rest of the world. As long as we had to make that plutonium and we might say keep Russia at a distance.
So anything I haven't asked you about in terms of your work at Hanford that you'd like to talk about?
Well, no, other than the fact that once I went to work in the 300 areas, I worked all over the United States. Because I happen to be, you might say, an expert on nuclear reactors, and when they, a good example is that the government decided they wanted to have every nuclear reactor, I'll say described, to be sure, what it is, and how much radiation and so forth is involved. In other words, they did that, they licensed them. And that was quite an interesting job.
Right.
Because I worked on 7 reactors back on the East Coast. And of course I worked for 1 year in Oak Ridge.
Right.
And that involved all of the AEC facilities. Anyway.
Well, I want to thank you very much for coming in today and sharing your experience with us. I really appreciate it.
Well, always glad to be helpful.
Thank you very much.
But I would like to see the facts published in your story that low-level radiation is beneficial.
Well, I'm making these. We're making these available for anyone to look at the oral history stuff. Yeah. Thanks again. Appreciate it.
Okay.